On. Yep. Now take the sliding part. And this is really important, guys. Can everyone kind of see what's happening here? This slide comes up here, and that's the, everyone, be quiet. A little click. Okay? Why is that so important? Anyone think? Why is this so? It's the most critical thing you can do. If you disconnect, it could fall in the well. Where are we putting this? In the water, right? What that does, that ensures that it's not going to get wet. That ensures the waterproof connection. It seals it. That's the whole idea. That's the big failure point that we see. People don't remember that they think they just kind of, I don't know, I'm going to put it together and keep put it down there. No, this is very important. The other part we talked about is lining it up. Critical point there. Line we can all take a look at what we have in here. But you want to line that applies to any plug. It doesn't have to, it could be plugging your cell phone charger in, right? Make sure it's lined up, okay? Is very important. But this will ensure that now, once we hear that click, we know it's sealed. It's not going to leak, okay? Now, we have a real short cable here, so it's not that big of a deal. So we're going to go ahead and put this down into our well. Well, we're going to put it down in the well right now, okay? Because typically when we put it down in a well, we're going to go down a distance, right? And I don't need a bunch of other stuff hanging out, okay? So we're going to go ahead and put this down in our well, our quote-unquote well, okay? So we're going to go ahead and put it in the well, which is the bucket right below your feet. Put it right in. Just go ahead and rest it right in, all the way at the bottom. Just let it go. All good. Okay, it's down in our well. Are we done?
Yes.
No. We don't even know what it's doing yet, right? Okay. So now we have this device, Bluetooth, exactly. So this is now how we talk to it, okay? So let's have someone else do this. It's the same exact connection. By the way, before I do that, can you guys all see what this connector looks like?
Yes.
So you guys all see that? That's the different plug that we're talking about. So you'll notice that when you're looking at this, you can imagine the one that goes on the other side of it is just the opposite. So that's why you have to match them up. Does it make sense? It's not like a USB-C connector. You can't just do it anyway. I'd love it if it was. Okay. So let's have someone else connect this up. Who else wants to do it? Yeah, here we go. Okay. So remember, you kind of line them up. Yeah. Nope. Yeah. And so we want to push it on so you can come down. Down here. Yep. Yep. Push on. Make sure it's lined up.
Okay, line it up and then.
Yeah, no, it's okay. So try. So you want to push. You're going to hold from down here. Make sure it lines up. So you can see how that fits. So the two half-moon pieces have to, kind of mount on top of each other. Yeah. It takes a little bit of push, right? It's okay. That's okay. It's okay. But I think this is a good point that it takes a little bit, but not a lot. And so that's hard to. You want to make sure you get that lined up. Okay. Now, you heard the click, right? Okay. Which is very good. Okay. So let's go ahead and turn this on. So how do you think we turn it on? Anybody? They push the button, right? Okay. So we turned it on. Now here's the fun part. Now I'll show this around everybody. We're gonna do this on my phone. Okay. So I have our app opened up here. Okay, you guys can all see this?
Yes.
And what I have here is there's a device name that's connected up here. Okay. And that's called our power pack. Okay. So what I'm going to do here is I'm just going to click on that power pack. It's going to connect up. And the cool thing that we have here, if you guys, it had it up here, is actually telling me what the instrument was that's connecting. So right now, this is actually the name of the instrument. You're able to see that Aquatrol 200. That's just the product name. That's all it is. But the serial number is there too. So I know exactly what instrument I'm always connected to. Right up top here in the blue. You guys see that?
Aquatrol 200.
Aquatrol 200. The Bluetooth, this should not be submerged. Because there's no reason for it to be submerged. Because Bluetooth doesn't work in the water.
Accidentally, I fill water into it.
Bad idea. Not
It's not IP certified.
It's not IP68. Yeah, so do not do that.
And that's why we're using a cable.
Exactly, that's why we have a cable, and this is why I wanted to. However, if you're working in the rain, this will be fine. I wouldn't splash proof. The thing you have to be careful of on top of this is there's a charger port on here. Keep that dry. Very important. Another thing on that, on particular on this, if any of you ever dealing with salt water, seawater, any environment, or maybe there's brines or something like that, you're going to keep that off of this. Because that salt water can be very corrosive. Okay, that's a universal thing, by the way. Just be very careful about it. Okay, so what we've got here, the other thing we have on here is we got some information on our unit. This is the same screen we were just looking at before, but we have some menu items at the bottom. Okay, we have things like live readings, logging, calibration, instrument settings, things like that.
We have to put some code for connecting this instrument.
For connecting it, we're connected to it.
Nothing is needed. Just like a
Bluetooth. Wireless.
Automatically paired.
Kind of nice. Okay. So the thing we're gonna check out here real quick, just because we can, is I'm gonna go to live readings. Now, with this type of instrumentation, I wouldn't necessarily use this, but it's a good way to kind of check what we have going on with the instrument. So I'm gonna go ahead and hit live readings. Okay, my screen changes. I'm gonna wait till it comes up, and then we're gonna look around here. You guys see all those different parameters that are on
Yes,
there?
temperature, pressure.
Pressure, temperature, actual conductivity, and specific conductivity. Salinity. We didn't even talk about salinity.
Yeah, you did.
We didn't mention it, right? Anybody know why we didn't mention it?
Because we are working with groundwater and our
Fresh
climate
water.
market is fresh water.
Well, is it? So actually, salinity is very, very important in groundwater. It's a great concept here to talk about. Particularly when you get into coastal areas, you get a thing called saltwater intrusion. Okay, you guys may have studied that, right? So that is a critical part in groundwater. And so salinity can be an essential measurement, right? Okay. Remember though, I didn't mention anything about that we had a salinity sensor, right? How do we calculate salinity? From conductivity, right. What does this sensor have on? Conductivity, right? So that's one of the great things about an instrument like this, that you can get other parameters out of there. There's another one on here. What does that one say right there?
Total dissolved solids.
Total dissolved solids. TDS. You guys know about TDS?
Yes.
Right. How do we get TDS from the sensor? From conductivity. Another correlation that happens from conductivity. Remember how I said they're the two most important water quality parameters we can get? Temperature and conductivity. This is why. We get some really, really good information. Okay. Now, how we get to, so for total dissolved solids, that does depend on the actual water we have here, and it's a correction factor, it's just a multiplier, and that's it. Okay. There are standards for it, they get kind of close. I believe it's about 0.65, might be 0.62, I don't quite remember. And that's what's actually built in here. But you can change that based on your water. So if you took this out for a lab sample and said, hey, my conductivity, instead of being, or my total dissolved solids, excuse me, I have it at 0.23 parts per thousand right now. Maybe it's, I don't know, 0.6. Well, then you can adjust that calibration factor for your particular water. That's the case. But so what we're seeing here is just all our parameters recorded. Okay? You can see them. Just get an idea of what's happening. Okay, the most important one we have on here, I think, is, it's down here, is depth. Okay? Everyone see this right here? Depth. All right. What does it say? It says 24.83 meters.
Yeah. So that's from above the mean sea level, or something like that.
Are we at 24.83 meters of water right now?
No.
No. Not at all, right? Okay. There's a concept here I'm just going to introduce real quickly to you guys that I encourage you to learn a lot more about. Okay. This concept of vented versus non-vented pressure transducers. Okay. A vented pressure transducer measures gauge pressure. You guys heard that? The difference between absolute and gauge pressures and atmospheric pressure, which is really any pressure readings. You guys may have heard that. So absolute, absolute pressure, when we measure any pressure, is measured relative to zero. It's a simple way of thinking of pressure, okay? Because it's measured relative to a vacuum, which is zero. However, when we think of pressure, we think of things like pushing down on something, right? Okay, so if I push down on this table right now, we're only worried about me pushing on the table, right? However, if I don't push on it, is there a pressure acting on that table?
No.
Yes.
Atmospheric pressure, right? That's what. So when an absolute pressure sensor on, if I put a pressure sensor on this table right now, it would read atmospheric pressure, and then when I push on it, it adds it right up, right? So it's the atmospheric pressure plus what I'm pushing down. Okay, that's the absolute pressure. From a gauge pressure standpoint, what does it do? It subtracts off atmosphere. It's relative to the atmospheric pressure, which means the only pressure I'm getting is what I'm pushing on it. Okay. There are two different types of technology that you have to have with these submersible pressure transducers. This unit that's in here is an absolute pressure. It's called non-vented. That's the term for the sensor, non-vented. But it's measuring absolute pressure, which means the pressure that we have acting on that sensor right now is
The equivalent pressure to the atmospheric
atmospheric
pressure and the water.
and the water. Atmospheric plus water. Okay, that's what's actually acting on it right now. So let's just do one thing. Go ahead and lift that out of the water. I'm just gonna hang it right there. Okay. So now this says. So we actually have this. Well, there's a whole separate thing. This now says that my depth to water. Remember what was it for? 24. Now it says 25. Now there's another concept here which we have to think about. Let's think about. Let me go back. Actually, look at something a little more. Right now, let's think about pressure. Just pressure. Pressure is right now it's 14.69 pounds per square inch. Go ahead and put it in the water. It's now 15.03. Does that make sense?
Yes.
Think about what we just talked about with pressure, right?
Yes, it's me.
So we had 14 point, whatever I said. That's what?
That's what
Atmospheric pressure, right? Does that make sense? Is that
Yes.
number correct? What if it read 35 psi? Would that make sense? Definitely not, right? We'd have to be really, really deep in the earth with big open, a lot of atmosphere on top to do that. About 14 psi, 14 and a half psi. It's pretty standard. Right here, where we are at this elevation, makes perfect sense. Where I live, I actually live at about 2,500 meters, and it's a little lower. It's below 14. Okay, but not much. Okay, but that's where that's one thing you want to check this out. But now we're reading 15 psi, so we've gone up about half a psi.
half PSI.
Does that make sense?
Yep.
That water pressure adding the atmospheric pressure.
Added on top of that. So that's all we have. We're just putting this in a bucket that's only what, 20 centimeters? I don't know.
30 or
30 centimeters, maybe?
30, 35
Yeah.
maybe.
Yeah, actually, well, sorry. It should be 30 to 40 centimeters. Sorry. But yeah, so that's all the water that we have on top of it. So my point here is that by using this live reading on here, you can actually see some of these reads and make sure your sensor is doing what you think it's actually going to do. Okay. Now we did talk real quick because I do want to get to this because there's a concept. We talked about this thing of depth to water. Okay.
24.82 meters.
Yeah. So depth to water on there, and that's the first one we were originally talking about. Depth to water. All right. I don't see that. Depth to water. That's the one we originally read. Right. 24. Okay. What is depth to water? Think of the words. the depth to the water. I think we disconnected her, that's okay. Well, remember we have a well, right? Typically we're thinking, in this case, we've got our bucket down there, so I need the depth to that water, which would maybe be relative to a reference point. So how about we use this table as a data? Exactly. So then it's the depth from this point, this arbitrary point that we've defined, down to that water. Okay. That's a very typical measurement in groundwater, right? We use a water level tape or something to measure that. We could actually figure that out. Because we're measuring the pressure of that water, which is over the sensor, we have to apply a reference value to convert it to depth to water. Because that's a measurement that we may take directly, or we can more easily, we may measure in different methods. So that's what that is. So the fact that this is reading 24.82, what that means is we have a reference value in there that is probably set somewhere probably around 24 point, yeah, around that. So what happened when we pulled the pressure transducer out? Go ahead and do it again. Right now remember 24.83. And now we're at 25.04. Why did the number go up?
Because we are above the sea level, and if you lifting the sensor is heading up to
reference point is set below
Down.
the measurement point.
The reference is actually below there. So what happens is the depth to water. Remember what I'm measuring. I'm measuring from here to the water. Okay? Which means if we left that in the water, okay, let's think about it. Let me grab, oh, there you go. Oh, no, it's right here. This is another pressure transducer. So this is in the water, and I've got a water that sits here. Okay? And what I'm measuring is from some point down to here, right? So, what happens if so my depth of water was, say it's 10 meters. If the water level goes down here, what's my depth of water? Is it greater than 10 or less than 10? Greater than 10, right? So that means my water level goes down, my depth of water goes up. So it's an opposite of sometimes what we think about. Same thing, the water level goes up, depth of water goes down, right? Okay. So that's the whole reason why what we've done is we've actually now pulled that out. So now a greater, what appears to be a greater depth of water because we've actually decreased the pressure on that. So by pulling it out, what we've done is so remember, all we're looking at is the depth above that sensor. So we reduced it down. And in fact, we reduced it down so much that we took it out, right? But it zeroes out at the reference value that we have. So that's why that happens there. That can be confusing sometimes. There's other ways you can look at water level. You can look at it in terms of elevation or just depth itself. So elevation is really important relative to mean sea level. It's a very common one to do, helpful for comparing water levels between different places. And then the just depth, like I said, that's just the elevation of the above the sensor. Okay. So real quick, guys, I was going to say, so we looked at some of our parameters. I'm going to go back out on this, and I just want to show you something here. We're going to do one thing. So these all have data loggers. They can record data. You don't just have to look at the live readings and say, I got to write it down. There's a whole other section on here called logging. Okay, another, and again, remember I said how easy this is to use? When someone says set up a log, well, maybe go to where it says logging. Okay. So I'm just going to click on it real quick. I'm not going to go through this whole process because I want to be respectful of time. But there's basically an idea where I can set up a whole new log in this. Okay, and I can do everything from naming it. I'm just going to kind of bounce through this a little bit. I can choose a location. These locations on here are based on my phone. But I can set a new location. Well, that's kind of nice. Maybe actually perhaps there's data in there that you need for the different locations that I have. So you can add a new one. In fact, we have one here called the DU well, Dhaka University well. So we're going to click on that one. And then I just hit next. And then we have all our parameters that we want to choose to do on there. And you can select them. You don't have to get everything. Okay, you choose what parameters you want. You don't worry about salinity. I don't want it. So I'm going to collect everything here. I go next. Okay, remember we just talked about this with depth to water, depth and surface elevation? This is where you set. It's all right here. This is that. Okay. And so if I did depth to water, remember we talked about that reference? This is now I set that reference value. Which means in order to do that, I have to actually measure that first distance using that device. Okay. This is where we go. So we can enter that reference. Okay. I'm just going to do depth real quick. I hit next. Yeah. By 12, we'll wrap right up. But thank you so much. So real quick, another thing we talked about salinity of the water. Is salt water more or less dense than fresh water? More dense, right. Does that change the pressure at a certain point?
Yes.
Yeah, it does, right? So it's really important to understand the density of your water when you're doing pressure measurements. Right? Really cool thing with this sensor, because it has that conductivity sensor in there, it can actually be used to calculate density. Which means if you're in an environment where the density of water could be changing, saltwater intrusion, great example there. But maybe you got another, maybe it's just, I don't know, could be something else, industrial discharge or something like that. This is a great tool because we can actually do automatic optimization of our density. Or you can just choose a standard, freshwater, brackish water, salt water. Or you can put a custom one in. Maybe you have your own type of fluid that you know the density of.
More contaminated.
So wait, you hear what I just said? Your own fluid.
Yep.
That means you don't necessarily have to use that just for water. You got to be careful with chemical compatibility and things like that. But if you had another fluid, you potentially could use it for that instead of custom density. Okay. I'm going to jump ahead to ideas that you just basically set up the idea of, kind of how often you want to take your reading, and then you set it to go. And that's, you basically just connect it up there. You can then let it run, and then you can either come back and download it again with using this setup, or you can do all of this
Using the telemetry.
And there's no difference in the setup except for one critical part. This is an essential thing to understand. This is actually one of these Bluetooth device plus its own data log. This actually acts as another instrument to this. The thing that it doesn't have is a sensor. You tell it what sensor to connect to. So what that means is with telemetry, I can have data logging on this and data logging on that. And I can connect to it wirelessly just like that using this. So this is a real nice feature because you could actually just use this to connect all your stuff. It's a lot bigger, but it has replaceable batteries. And it's all a nice feature and stuff like that. So a couple things to think about, like data redundancy, data security. I know you all have to run. I want to be respectful of your time. But any quick questions? Yeah.
GPS installed in that.
This does actually have GPS. Yeah, it does. The other cool thing, we talked about location. You can use the location on your phone GPS. It's actually fine. Everybody talked about doing the well right out here in the courtyard. We did some training with that. I was able to just find out. We'll use Google Maps. Just use the location on my phone. I can click on it and set that location. But this also does actually have GPS in it, which is nice. It can be helpful if you want to know where it is in the world. Anything else? Good?
So the market.
Yes. I want to say, so we were here a few days ago teaching some of your other students here. You guys are truly amazing. I really want to tell you this. I teach all over the world. We were just talking about this. You guys are the most engaged group of students I've ever had. And this is universal, okay? So you guys should all be proud of yourselves. Keep asking questions. These are fantastic. From now on, always ask questions. Be inquisitive about this stuff. That's the most important thing you can do. So be curious, okay? Always just ask those questions and you're going to go far. And you guys make me feel really good. I'm gonna get emotional about this. It's like, because you guys make me feel that our water resources are in good hands. Okay, and it means a lot. So keep up the great work. Keep doing what you're doing. Learn from your professors. They're great people. Okay, but also network. Get out there. There's so much to learn out there, and take it all in and apply it wherever you need to. Here in Bangladesh, anywhere in the world, because your skills are valuable. So keep up the great work, guys. Appreciate it.
Wish us luck.
Thank you.
Thank you so much.
Thanks.